Now see here, transistor as an amplifier we have done, and now here we are going to do transistor amplifier, which we are using also to make oscillator. So we are actually going to do the working of the transistor as an oscillator. So see here, in an oscillator we get output without any external input. So we can say oscillator is a self-sustained device. What happened in this case? Suppose you have got here the transistor amplifier. This is your transistor amplifier. These are the two parts we are getting as output here. Whenever there is a decrease in the output part, so what we do here, take from here in this side, and we use here the feedback circuit here. This is called feedback, and in this case this is going to this and this is going to this. So here we take a portion of the output in the same phase and here feed it to the input side. By this way the output remains always same. So we can get output without any external input. So from the circuit itself only we are taking from here output side and feeding it to the input side. This is called the feedback circuit or the positive feedback because we are feeding in the same phase. Now see the circuit diagram for the transistor as an oscillator. First one, again we will be using here the NPN transistor. Suppose we have got this is here NPN transistor in this case, and in this case here this is collector part. Here we use a capacitor and here we can use here inductor. Suppose we can take here this capacitor C here and this is inductor here, this coil here T1. Then it is connected to the battery here and the reverse biasing this side always. So obviously this has to be positive and connected to this side here. Now we use here another inductive coil which are coupled together like this, and here this is connected to this base and this is connected with the battery here like this. Here is positive feedback. This we can take as VVB and this we can take as VCC. Now in this one, these two are coupled together. Suppose this is T1 and this is T2 and we can measure here the output to this side. Now what happened in this case? As this circuit is switched on, this switch is here, S is closed, a surge of collector current flows through this. As the surge of collector current flows through this, now what happened in this case? As this circuit is switched on, this switch is here, S is closed, a surge of collector current flows through this. As the surge of collector current flows through this capacitor, then there is an induction in this coil. Now see the collector current increases in this part if you are taking IC and time here. So collector current are flowing in this way. When the collector current are increasing here, so capacitor is actually getting discharged, and when the collector current increasing and going to this, since this coil is coupled to this, there is also induction, and induction is such that which is supporting the forward biasing of the input side. This is called feedback. This you are actually feeding from output to input side. So when the collector current is increasing, as a result ammeter current is also increasing here like this. So ammeter current and collector current are going in this way. So when the collector current reaches to the maximum value, ammeter current also reaches to the maximum value. When the collector current reaches to the maximum value, there is no further induction. It means current stops growing or the changing here. Because of that, collector current now induction stops, as a result induction stops here. So feeding has been stopped now. Because of this, ammeter current start decreasing, and when the ammeter current start decreasing, collector current also keep on decreasing. So here if you have taken x, y, z, here x dash, y dash and z dash. So you will see here the collector current is going to the maximum value, coming to the 0. Similarly, ammeter current is going to the maximum and coming to the 0. By this way, Now, when the emitter current has become 0 and collector current has become 0, so transistor has reverted back to its original position. So, now in this case here continuously there is oscillation of the current, right, from 0 to maximum, maximum to 0, 0 to maximum, maximum to 0, and this one is also known as here the tank circuit here, and this oscillation and the frequency of this oscillation is given here, that is here nu is equal to 1 upon 2 pi under root of L C. This is the frequency of the oscillator. So, we can use here this transistor as an oscillator, right, and here in this case this circuit can be used in way, I think, in a communication, or you can say as a receptor in the different devices.